All right. Good evening. You're welcome to our today's lecture. Today we'll take a look at the course HCG 322. So we'll talk about what? Drugs of pharmaceutical biological origin. We are still on the topic drugs containing carbohydrates and derived products. Drugs containing carbohydrates and derived products. In our last class, we introduced carbohydrates and we defined carbohydrates, what carbohydrate is, and we stated the reason why the meaning of carbohydrates is not actually true. So we now redefined it using the what? The chemical structure. It was redefined using the word chemical structure. Please watch that lecture, our last lecture on this. Once I fix any lecture, that lecture must hold. Then if I'm able to record the lecture, those that missed the lecture should go and watch the lecture. So we're not going back to these things we've done, but I'm just trying to tell us what we have done so far. So we also went straight to classification of carbohydrates. So that's exactly what we did in our last class. So we classify carbohydrates starting from the simple sugar, that is saccharides and polysaccharides. Then we went down to saccharides, where we have the monosaccharide, disaccharide, trisaccharide, tetrasaccharides, and we gave examples of each of these sugars and the under each of these saccharides. So we gave examples of them, even polysaccharides. Please watch that lecture. Watch that lecture. I sent the link last time we had PCG 322. Now today we are going into another thing. We want to take a look at the test for carbohydrates. We look at test for carbohydrates. Test for carbohydrates. So we look at the following useful tests for sugars and other carbohydrates. So the first test I want us to look at is the test that involves reduction of Fehling solution. It's a test for simple sugar. For this test, once you get a sample that is, you want to check whether it's carbohydrate or not, what you simply do is this. Then get that solution, add equal quantity of Fehling solutions A and B. Once you add equal quantities of Fehling solution A and B and heat a bit, then after heating it, if you notice brick red precipitate, then that sample contains carbohydrates. So it's a simple and popular test. Then the next test is Molisch test, MOLISCH test. Now, basically, this test is positive with soluble as well as insoluble carbohydrates. So both soluble and insoluble carbohydrate test positive to this test. So how do we carry out this test? Now, what actually happens is that if you treat a compounds with alpha naphthol and concentrated sulfuric acid, if you treat carbohydrates with this alpha naphthol and concentrated sulfuric acid, it will give purple color. Now that one is for what? Insoluble carbohydrate anyway. Now the point I want to make here is that if you get a soluble carbohydrates and use it for this test, you notice something. A ring will appear, and that ring that appears, if you gently pour sulfuric acid, it will form a layer below the what? Aqueous solution. It will form a layer below the what? Aqueous solution. But if what you are dealing with is insoluble carbohydrate like cotton wool, cellulose, now this color will not appear until you shake the acid layer to make it come in contact with the what? The material. I will repeat myself. I said for molage test, the basic thing that we should understand about molage test is that it can be used for what? Insoluble, soluble and insoluble what? Carbohydrates. And you just what happens here is that the compound in question, the one we want to test, whether it is soluble or insoluble, you add alpha naphthol and concentrated sulfuric acid. Now this it will give you a purple color. Now, but if the one you are testing is soluble carbohydrate, this purple color will appear as a ring. As you gently do what? Pour the what? Sulfuric acid. As you gently pour the sulfuric acid. Then you now notice the lower layer below the ring will be aqueous what? Solution. Now, but if it is with an insoluble carbohydrate like cellulose, this color will not appear unless the acid layer is shaken to the extent that it gets in contact with the material. Now, another test is oxazone test that has to do with oxazone formation. So basically, oxazones are just sugar that are formed by heating sugar solution with phenylhydrazine hydrochloride, sodium acetate and acetic acid. So if you heat sugar solution with phenylhydrazine hydrochloride, sodium acetate and acetic acid, oxazone will form. So it's a sugar derivative. Now, if a yellow crystal is formed when examined under the microscope, a yellow crystal is formed, then you don't need to be told that it contains what? Sugars. But basically some sugars like glucose and fructose actually form the same oxazone. It is called glucosazone, which has a melting point of 205 degrees Celsius. Now, but this oxazone is not noticed when sucrose is involved. In other way, I'm trying to point out that the sucrose does not form oxazone, but actually under the condition if subjected to the same condition with glucose and fructose, hydrolysis may take place to form glucosazole. What I want us to take home from here is that if you subject, maybe if there is a sample suspected to be sugar, and you add phenylhydrazine hydrochloride, sodium acetate and acetic acid, yellow crystals will be formed. And if this yellow crystals is formed, it's clear that this sample is what? Sugar. Specifically, fructose and glucose form glucosazole, which is an osazole. They form the same osazole, which is glucosazole, basically. But sucrose does not just form it like that. For sucrose to form it must be in condition that we have there must be sufficient hydrolysis have to take place. Remember, when hydrolysis take place now, sucrose we split into two. Remember, so when that happen now, that means it will come down to simple sugars, so that this phenylhydrazine hydrochloride and sodium chloride acetate and acetic acid will now react to them to form the what? Glucosazole. Now, another test I want us to look at is Sullivan's test. Sullivan's test, or is also known as Resorcinol test, is used for ketones. It's used for ketone. If you have a sample, you don't know what it is, and you suspect it to be anything, all you need to do is to add a crystal of resorcinol to that solution you want to test, and warm on water bath. Then you also add what? Equal volume of concentrated what? Hydrochloric acid as you warm. If after adding these things you notice a rose color, that means ketone is present. Resorcinol test. Crystal resorcinol added in solution, warming in water bath with equal volume of what? Concentrated hydrochloric acid. If you notice a rose color, ketone is what? Present. You start seeing example fructose, honey, or even inulin hydrolyzed. Then from the classification, I don't know if you went through the I don't know if you went through the last lecture on the classification of carbohydrates, where we mentioned some under monosaccharides. We have bioses, they contain 2 carbon atoms. We have trioses, they contain 3 carbon atoms. We have tetroses, they contain 4 carbon atoms. We have pentoses, they contain 5 carbon atoms. Pentoses example: ribose, arabinose, xylose. These ones are what? Pentoses. So if you remember that we are not talking about test for these pentoses. Those ones are contain 5 carbon atoms. If you have something, a sample you suspect, you want to know whether it is a pentose sugar, so all you need to do is to heat it in a test tube with an equal volume of what? Hydrochloric acid. Then that contains a little fluoroglucinol, not FO, PHLORO, fluoroglucinol, then GLUCINOL, that contain a little of it. If you notice red color, if red color is formed, that sample is a pentose what? Sugar. Let me say it again. I say that if you have a sample you want to test whether it is a pentose sugar, simply put it in what? Test tube. Warm the solution. It should be in solution form. Warm it in test tube with an equal volume of hydrochloric acid that contain little amount of what? Fluoroglucinol. So if you notice the red color, that sample in question is a pentose what? Sugar. Is a pentose sugar. Then we also look at the oxy sugars. We have to test for what? The oxy sugars. Remember, you are the oxy sugars. The oxy sugars. The oxy sugars are found mainly in cardiac glycoside. The oxy sugars. The oxy sugars. So if you want to test a sample to know whether it is the oxy sugar, all you need to do is to, first of all, that particular sample in question, you dissolve it in acetic acid that contains a trace of ferric chloride. Dissolve the sample, you don't know what it is, in acetic acid that contains a trace of ferric chloride. Then when this is done, then you transfer it to the surface of what? Sulfuric acid.
Your network is sound bad everywhere. Yes.
Hello, are we together? Please feel free to ask question at any point. Feel free, okay? Please feel free to ask question. If you have any
Yes,
question.
but your network kind of.
Hello?
Yeah.
Please, if you're not asking question, please mute your mic, please.
Yes, sir. All right, no problem.
Thank you. I say that, let me repeat myself. We want to look at the test for the oxy sugars. I said that the oxy sugars are found in cardiac glycosides. Now, the name of the test is called Keller-Kiliani test. Keller-Kiliani test. Now, I said that if you have a sample you want to test whether you don't know what it is, you should first of all dissolve it in acetic acid that contains a trace of ferric chloride. So when this is done, you transfer whatever the mixture to the surface of concentrated sulfuric acid. And if you transfer it to surface of concentrated sulfuric acid, you notice something. If you notice at the junction between the two liquids, that is the liquid solution, the mixture you form by dissolving the oxy sugars in acetic acid with a trace of ferric chloride, at the junction between that solution or the liquid and the sulfuric acid, at their junction, if you notice a reddish brown color, that gradually becomes blue, if you notice a reddish brown color that gradually becomes blue, it means that the sample in question contains the oxy sugar. If the sample is a deoxy sugar. Now, another test I want us to look at is the furfural tests. Furfural tests. So what is this all about? Now, in this test, basically, if you hit any carbohydrate sample in a test tube with a drop of syrupy phosphoric acid, it converts it to what? Into fufura. Carbohydrate sample, heat it in a test tube with a drop of syrupy phosphoric acid, it converts it to what? Fufura. So what it means is that if you have a disc of filter paper that is moistened with a drop of 10% solution of aniline in 10% acetic acid, and place it under the mouth of the test tube, then heat the bottom of the test tube for like 30 to 6 seconds. A pink or red stain will appear on the filter paper. That paper you use to cover the what? That paper you use to cover, the paper already soaked with moistened with what? 10% aniline solution and what? Acetic what? Acid. So in a nutshell, what am I trying to say? I'm talking about the chemistry. Now let me break it down to what I'm trying to say here. Let me break it down to what I'm trying to say. Hope you can hear me. Huh? Hello? Please unmute your mic and talk. Please let me know whether you are following me. Hope you can hear me. Huh? Please, let's talk now. Hello? 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 Am I speaking to myself? Okay. Now, I'm talking about the chemistry. Let me now break it down so that you understand what I'm talking about. So basically, I'm trying to say that fufura tests basically they are used to detect the presence of pentose sugar, like 5 carbon sugar 2. So the basic thing there is that all those aniline 10%, acetic acid 10%, if you mix it with the substance in question, you suspect to be pentose, and heat it. If there is pentose there, they will react with aniline and the acetic acid to form fufura. Basically, that's what happened. Basically. Remember, we made mention of what? Pentose test before. Remember that? We made mention of the pentoses. Yeah. So fufura test is also there. Can also be used to test for what? Presence of pentose sugars too. Please, let's note that point. So following the techniques here, where you have that the disc of filter paper is moistened with 10% aniline and 10% acetic acid. Then you place it on the mouth of the what? the test tube. The test tube that contains the what? The material, the test solution. Then you now hit the bottom of the test tube for like 30 to 6 seconds. Then a pink or red stain will appear. So that if it appears, that is, it means that fufura has been formed, and that is a test that to show the presence of what? Pentose. So I decided to be specific now. Pentose. So maybe if you have a plant extract like sugar, plant extract that sugar and other carbohydrates, you can use fufura test to check whether there is a pentose is present in it. Very important. But there's a problem with this test too. It's not specific to pentoses. It can also react with other compounds such as hexoses and uronic acid. So that is the issue we have. So that means you need further confirmatory test. Maybe after this now you can now, if let's assume you did the first one and you notice that that this pink or red color is formed, you can proceed to the other one. The test I gave specific test for what? Pentoses. So this fufura test is not specifically for pentoses. That's the point I'm trying to make. It can be used, it can give positive result for hexoses. So but if you use it and it gives you positive result for pentoses, then go further and carry out specific tests like the one I described before now for pentoses. The one I described before for pentoses, where you heat the solution in a test tube with an equal volume of hydrochloric acid that contains a little fluoroglucinol. So if a red color is formed, it's confirmed, it is clear that this actually contains what? Pentoses, pentose sugars. All right, so now that's the test. That's fufura test. That's the fufura test. Are we together? I don't know if you have any question. Does you want to enter?
No, sir. Together.
Is there? If you have any question, please ask. That's the much we
No
can take
question.
on
No
the
question.
test
No
for
question.
carbohydrates.
No question.
Because after this, we are going to how these carbohydrates are synthesized. That is the biosynthesis of carbohydrates. So we'll pick the one after the other and look at their biosynthesis. All right, so that's the next thing we'll look at now.